Hello guys, welcome to our channel, and today we are going to see the 15th sum of exercise 3.2 chapter 3 matrices class 12. So I am just representing each and every sum in one page, which is very easy so that it gives me more space in the whiteboard. So the 15th sum is find a square minus 5a plus 6i if a equal to the given matrix. So just we need to find the value of the equation that is given. So the first step which we are going to do is find the value of a square, that is nothing but a dot a. So multiplying the 3 by 3 matrix to itself to find the value of a square. So we are going to multiply this to the general multiplication to yield the product. So that will be the value of a square that is asked in the equation that is to be find, right? So when we multiply this first row with the first column, we get 2 2s are 4 plus 1 1s are 1, so that is 5. Then this with this you yield 2 2s are 4 plus 2 plus 1, so 6 9. 2 1s are 2 plus 2 into minus 1 is minus 2, so 0 0 1s are 0, so 0. Similarly, if we do this, we yield minus 1 minus 2 minus 1 2 5 minus 2. So the value of a square is this one, 5 minus 1 2, 9 minus 2 5, 0 minus 1 minus 2. Then by the equation that is given in the question that is asked, that is a square minus 5a plus 6i. So we found the value of a square is nothing but this one. Now we need to find the value of 5a. So 5a, so this is the value of a that is given, 5 into the entire value, that is just multiply as I told you in the multiplication process. 10 0 5, 10 5 minus 5 5 15 0. So this is the value of 5a, and they have asked us 6i, right? So 6i in the question is 6i, that is nothing but 6 into identity matrix 1 0 0 0 1 0 0 0 1. So that gives you 6 0 0 0 0 0 0 6 6. So we found the value of a square, 5a, 6i. So the next step is just merely substituting in the question or the equation that is asked in this question, that is a square minus 5a plus 6i, right? So this is the question, or this is the given equation that we need to find the answer. So we got the value of a square as 5 9 0 minus 1 2 minus 2 5 minus 1 minus 2 minus 5a is nothing but 10 0 5 10 5 15 5 minus 5 0 plus 6 0 0 6. So when you simplify with respect to the position of the numbers that is present in the matrix, you yield the answer as 1 minus 1, then minus 3, here minus 1, 0 minus 5 is minus 5. Similarly, minus 1 plus 5 is 4. Minus 2 minus 2 plus 6 is again 4. This gives you minus 10. This gives you minus 1. So this is the value of a square minus 5a plus 6i that has been asked in the question to find, right? So the 15th sum is over. The 16th sum. Now this sums they have asked us to prove that a cube minus 6a square plus 7a plus 2i equal to 0, and the given value of a is the 3 cross 3 matrix. So again we are going to individually find the values of given things that are in the equation, that is 6a square value, 7a value, a cube value, 2i value, then merely substituting in the equation and check whether we get the result as a 0 matrix is what we need to do in this sum, right? So first we will find the value of 2i. 2i is nothing but is a 3 by 3 matrix, so it yields 2 0 0 0 0, I mean 0 2 0 0 0 2. Then we will find the value of 7a. Multiplying 7 into the given a matrix will give you 7 0 14 0 21 7 14 0 14. So then we need to find the value of a cube and a square. A square is nothing but multiplying this two to yield the result a 3 by 3 matrix. So a square is nothing but 102 021 203 into the same matrix. So upon multiplying this row, first row and first column, second row and first column, third row and first column in order to yield the first column of the result matrix. So we get 5. Then multiplying this we get 2. Then 8. Here everything goes 0. And here again we get 8. Here 4, 5, 0, 13. So this is the value of a square. We get the value of a square, 7a and 2i. The next step is we need to find the value of a cube. So a cube is nothing but a into a square. So which makes us again a simpler. We got a square as 508 245. 8 0 13 into 1 0 2 0 2 1 2 0 3 is what the value of a. Again multiplying this two to find the value of a cube, we get upon multiplication 21 0 34 12 34 8 0 55 23. Kindly just check it out by calculating in your notebook. So we found the value of a cube and a square, 7a 2i. So just substitute that in the equation and find that whether the equation yields the value 0. We get a cube value as this one. So upon substituting the values which we arrived before to this equation, we yield the result that they are asking. So again we just write the same thing over here, or we just find the solution over here itself by just multiplying the 6 into the interior equation, that is of a square. So we get 30, we get 30, 0 over here, 30, 0 and 48, 12, 24, 30 and 48, 0, 78. So upon simplifying this entire matrix, we yield a 0 matrix. So this 21 minus 30 plus 7 plus 2 will give you 0. Similarly, 0 plus 0 plus 0 plus 0 will give you 0. 34 minus 48 plus 14 is equal to 0. So upon simplifying this entire equation, we get the 0 matrix as the result. That has been asked in the question to be proved as prove that a cube minus 6a square plus 7a plus 2a is equal to 0. So that is what we proved here. So at last you write this equation and write hence proved, right? So this question is over. Now we will go to the next question, 17th question. If A equal to the matrix given and I equal to 1001, find K such that A square equal to Ka minus 2i. Yes, again simply we can just find the value of A square and substitute in the equation in order to find the value of K, right? Again this is an easy question. So the A value is known. So A square will be 3, 4 minus 2 into 3 minus 2 minus 2, 4. So again multiplying this, we get the value of A square as 1, wait, we get 9 plus minus 8 as 1, 12 plus minus 8 as 4, and this will be minus 2, 3 into minus 2 is minus 6, plus 4 will be minus 2, 4 into minus 2 is minus 8, plus 4 will be minus 4. Similarly, we can find the value of Ka. So Ka, right, multiplying K into the entire equation, that is entire A matrix. So we get 3K minus 2K, 4K, and again minus 2K. So the next thing is 2i. 2i is nothing but 2020. So merely substituting these values in the equation, we yield the result that has been asked. So this is the equation which we arrived. So we just need to find the value of K over here. So everything, right, the first position of the matrix, if we multiply, we get 3K minus 2. We are subtracting, right? This is what given in the question. This is subtraction, right? So 3K minus 2 equal to 1 with respect to the position of the result matrix that is given. So we get the value of K as 1. So we can just again check it with the values that is present in this matrix and substitute it with this matrix to find whether we get the result present in the individuality elements in the matrix. So if we substitute here, 4 into 1 is 4, 4 minus 0 is 4. Again over here, minus 2 into 1 is minus 2. Minus 2 equal to minus 4. Again over here, minus 2 minus 2 is minus 2. I'm sorry, minus 2 minus 0 is minus 2. This is, as we got to find the value of k is 3k minus 2 is 1. So they have asked us to find the value of k, that is equal to 1. Right. Now the next question, that is 18th question. If a equal to 0 minus tan alpha by 2, tan alpha by 2 0, and I is the identity matrix of order 2, show that I plus a equal to I minus a into cos phi, cos alpha minus sin alpha, cos alpha. Again, right, the same thing. So we need to grind the same batter again and again in this matrix lesson. So the identity matrix of order 2 is nothing but, as we saw before, 1 0 1 0. Right, this is the identity matrix of order 2, and the a value that is given is 0 minus tan alpha by 2, tan alpha by 2 0. Again, merely substituting it in the equation, I plus a will yield you I plus a will yield you 0 tan alpha by 2, 0 minus tan alpha by 2 plus 1 0 1 0. Right, so that gives you the I plus a value as 1 1 instead of that 0 tan alpha by 2 minus tan alpha by 2 tan alpha by 2. Right, minus tan alpha by 2 tan alpha by 2. Similarly, for I minus a value, I minus a value, if we do the subtraction for that, these two values, instead of plus to minus, you yield the result to be minus 1, and here 1, oh, 1 minute, I minus a. So you get 1, okay, fine, I minus a, right? So we will just simply first find the matrix such a way that we can easily subtract it. So this is the identity matrix and this is the A matrix, 1 0 0 1 minus this value. So this yields as the value of I minus a, that is equal to, yes, so that gives you 1 tan alpha by 2, because 0 minus tan alpha by 2 will give you tan alpha by 2. 1 minus 0 is 1. This is minus tan alpha by 2. So this is what we get when we do find the value of I minus a. So what they are asked us, show that I plus a equal to I minus a into the cos alpha minus sin alpha. So just substitute it to the equation. So this is the, after substituting the values which we found, I minus a into cos alpha minus sin alpha cos alpha, that is the value of I minus a which we found is 1, tan alpha by 2 minus tan alpha by 2 1. So into cos alpha minus sin alpha cos alpha will, after multiplication, after multiplicating this, we yield the result that has been asked, that is to be, yes, the question that is to be, we need to find, that is to show, right, I plus a equal to I minus a into cos alpha sin alpha minus sin alpha cos alpha. We need to prove that we found the value of I plus a. Now after multiplying this, we need to prove that we yield the same result of I plus a as the solution, right? So that will be, so when we multiply this two, we yield this as the product, that is cos alpha plus sin alpha tan alpha by 2, then minus cos alpha tan alpha by 2 plus sin alpha, minus sin alpha plus cos alpha tan alpha by 2 sin alpha tan alpha by 2 plus cos alpha. by multiplying this 2. So this again when simplified we get this. Why? Because we need to find the result, or we need to prove that the result which we need to obtain is I plus a, right? So we need to get the value I plus a. So what they are doing is nothing but after multiplying this we arrive this equation. So over here cos alpha plus sin alpha into tan alpha by 2, that has been changed to cos alpha by 2 sin alpha by 2 by cos alpha by 2. That is, they are multiplying numerator and denominator by cos alpha by 2 over everything. I repeat, they are multiplying cos alpha by 2 numerator and denominator. Multiplying numerator and denominator. So as to find the value, so cos alpha by 2 sin alpha by 2 by cos alpha by 2. Similarly over here to the second one, minus cos alpha sin alpha by 2 plus sin alpha cos alpha by 2 by cos alpha by 2. Over there similarly, this again yields the value of cos alpha by 2 by cos alpha by 2. This denominator cos alpha by 2 remains same to everyone. So the numerator cos alpha by 2 plus sin alpha by 2 will yield you cos alpha by 2. That is actually cos alpha by 2 plus sin alpha by 2 will yield you cos of alpha minus alpha by 2, a general formula, that is cos of 90 minus theta. So cos 90 minus theta cos alpha minus alpha by 2 will yield you cos alpha by 2. So that is in the numerator. Similarly, sin alpha cos alpha by 2 plus cos alpha sin alpha by 2 will yield you minus sin of alpha minus alpha by 2. Similarly, over here minus cos alpha sin alpha by 2 plus sin alpha cos alpha by 2 will yield you sin of alpha minus alpha by 2. These are basic trigonometric formulas which we studied in our lower classes. And sin alpha by 2 plus cos alpha by 2 will yield you cos of alpha minus alpha by 2. Similarly, the same thing, that is present over here, both are same. So upon writing the values of that, we get cos alpha by 2, then cos alpha divided by cos alpha by 2. Similarly, sin alpha by 2 divided by cos alpha by 2 minus sin alpha by 2 divided by cos alpha by 2, cos alpha by 2 by cos alpha by 2. Again this value yields as yes, this one will give you the result as cos alpha by 2 by cos alpha by 2 will give you 1. And again this side the cos alpha by 2 was the right. This cos alpha by 2 plus cos alpha by 2 will give you again 1. And minus sin alpha by 2 by cos alpha by 2 will give you minus tan alpha by 2. And this will give you tan alpha by 2. That is sin alpha by 2 by cos alpha by 2 will give you tan alpha by 2. That is equal to LHS. Hence the proof, right, which we found before was the same. I minus a value is this one, right? That is what they have asked us to prove. We got the answer. So this is the answer for 18th question. We need to again implement trigonometry which we studied in our lower classes over here in order to get the result, right? So we found the value of for the question 18, we found the solution. We found the solution for 17th question, and we found the solution for 16th one, and for the 15th question. In the next video we will find the solution for the upcoming sums present in the exercise, and we'll move to the next exercise as soon as possible. So kindly subscribe my videos, and I try to update more and more in my videos like this. First I was using the entire book in the center and writing the solution. So I'm just updating, I'm just changing it to the new ways by which it could be very easy for you to understand, and I get a more space in order to take each and everything every step by step in the board itself, right? So kindly subscribe my channel to make me motivate posting more and more videos, right? Thank you.